Good afternoon. My name is Patrick Stelzer Reserva, and today I'm going to discuss about the round robin algorithm. So when we say round robin algorithm, it is a preemptive version of first serve. So when we say round robin algorithm, it has a time quantum or time slice, which the role of this time quantum or time slice, every process enter the CPU, it only gives 3 maximum time quantum milliseconds in order for that process to stay in the CPU, in order for other process to enter the CPU. Now let's get started. Now, we have here Gantt chart and guide. So we'll be using guide in order for us to know who is the process will come first in our CPU. So in here, we will check who is the lowest arrival time. So the lowest arrival time is 0. So we will implement it to Gantt chart. So we will put it to Gantt chart. I mean the ready queue is 0. Then after that, we will check who is the process will arrive in time 0. So the only process who arrives in time 0 is that the process D. So we will put it to our guide. Then after that, process D will automatically enter the CPU. Then after that, we will subtract the first time of it in our time quantum. So 3 minus 3 is equal to 0. Then what we subtracted will be added to its ready key. So 0 plus 3 is equal to 3. That is the time finish of process D in our Gantt chart. Then after that, we will check who is the process will come in time 3. So process C will come first because the arrival time is 1. Then process A will come after process C because arrival time is 2. Process A will come after process C because the arrival time is 2. Then after that, we will not put process D after A because process D, it has no burst time. It is already done because the burst time of it is already 0. Then process C will enter the CPU. Then in order for execute it, we will subtract the burst time of it into our time quantum. So 8 minus 3 is equal to 5. What we subtracted will be added to the time finish of process D. So the time finish of process D is 3. Then plus what we subtracted to the burst time of process C. What we subtracted to the burst time of process C added to the time finish of process D in our Gantt chart. So 3 plus 3 is equal to 6. That is the time finish of process C. Then we will check who is the process ID will come in time 6. So the first process will come in is process E because the arrival time is for it is the first process will come first. Then process B will come after process E because the arrival time is 5. Then after that, we will put process C after B because process C is not yet done. The first time has a remaining of 5 in our guide. Then after that, we will process A will enter the CPU. Then after that, we will subtract the first time of it into our time quantum or time slice. So 6 minus 3 is equal to 3. Then what we subtracted will be added to the time finish of process C. So 6 plus 3 is equal to 9. That is the time finish of process A, 9, in our Gantt chart. Then after that, we will, since all the process already arrives, we will just put process A after process C because it is not yet done. The first time of it is or has a remaining of 3. Then after that, After we put process A after C, um, process E will enter the CPU. Then after that, um, in order to execute it, we will subtract the burst time of it into our time quantum or our time slice. So 4 minus 3 is equal to 1. So what we subtract, that will be added to the time finish of process A. So the time finish of process A is 9, then plus what we subtracted to the burst time. So what we subtracted to the burst time of E. So 9 plus 3 is equal to 12. That is the time finish of process E, 12. Then after that, we will put process E after A because it is not yet done. It has a remaining of burst time of 1. Then after that, process B will enter the CPU. Then after that, we will subtract the burst time of it into 2 because it has only 2 burst time. So 2 minus 2 is equal to 1. 2 minus 2 is equal to 0. 2 minus 2 is equal to 0. Then after that, what we subtracted will be added to the time finish of process E. So 12 plus 2 is equal to 14. So that is the time finish of process B, 14, in our Gantt chart. Then after that, we will not put process B after E because it is already done. The burst time is already 0. Then after that, process C will enter the CPU. Then after that, we will subtract the burst time of it in our time quantum. So 5 minus 3 is equal to 2. Then what we subtracted will be added to the time finish of process B. So 14 plus 3 is equal to 17. Then we will write it to the Gantt chart in our time finish of process C, which is 17. Then after that, we will put process C after E because it is not yet done. It has a remaining burst time of 2. Then after that, process A will enter the CPU. Then we will subtract the burst time of it into our time quantum. So 3 minus 3 is equal to 0. What we subtracted will be added to the time finish of process C. So 17 plus 3 is equal to 20. That is the time finish of process A in our Gantt chart. Then after that, we will not put process A after C. We will not put process A after process C because it is done. The burst time of it is already 0. Then after that, process E will enter the CPU. Then after that, to execute it, we will subtract the burst time of it to 1 because it has a remaining only 1. So 1 minus 1 is equal to 0. Then after that, what we subtracted will be added to the time finish of process A. So 20 plus 1 is equal to 21. That is the time finish of process E, 21. Then after that, we will not put process E after process C because it is done already. It has a burst time of 0. Then after that, process C will enter the CPU. Then after that, in order to execute it, we will subtract the burst time of it into 2. So 2 minus 2 is equal to 0. So what we subtracted will be added to the time finish of process E. So 21 plus 2 is equal to 23. That is the time finish of process C in our Gantt chart. So here is our Gantt chart. Now to get the waiting time of each process, we will be using unit of ms or milliseconds. So in process A, to get the waiting time, we will be in the first parenthesis, we will with ready queue minus the arrival time. So the ready queue of A is 6 minus the arrival time, which is 2, so it's equal to 4. Then after the plus, second parenthesis, the second updated process A who enters the CPU, the ready queue of it is 17 minus the time finish of the previous process A who enters the CPU. The time finish of it is 9. So 17 minus 9 is equal to 8. Then 4 plus 8 is equal to 12 ms. Then after that, um, the ready queue of process B will be subtracted to the arrival time. So 12 minus 5 is equal to 7 ms. That is the waiting time of process B, 7 ms. Then after that, to get the waiting time of process C, the first parenthesis is that um, the ready queue of it minus the arrival time. So 3 minus 1 is equal to 2 plus second parenthesis, the second updated process C who enters the CPU, the ready queue of it is 14 minus the previous process C who enters the CPU, the time finish of it is 6. So 14 minus 6 is equal to 8 plus third parenthesis, the third updated process C who enters the CPU, the ready queue of it is 21 minus the previous process C who enters the CPU, the time finish of it is 17. So is equal to 4. Then after that, um, we will add it. So 2 plus 2 plus 2 plus 8 plus 4. So 2 plus 8 plus 4 is equal to 14 ms. Then after that, that is the waiting time of process C. Then after that, to compute for the process D, the waiting time of it. So the ready queue of process D is 0, then minus the arrival time which is 0, so equal to 0 ms. That is the waiting time of process D. Then after that, process E. In the first parenthesis, we will subtract the ready queue of process E into its arrival time. So 9 minus 4 is equal to 5 plus the second parenthesis, the second updated process E who enters the CPU, the ready queue of it is 20 minus the previous process E who enters the CPU, the time finish of it is 12. So 20 minus 12 is equal to 8. So 5 plus 8 is equal to 13 ms. To get the average waiting time is that we will get the total of all what we solved from process A to E. So 12 plus 7 plus 14 plus 0 plus 13 is equal to 46. Then we will divide it by how many processors we have. Since we only have 5 processors, we will divide it into 5. So 46 divided by 5 is equal to 9.2 ms. So the total is 46. Then we divide it by 5 because the total processor we have is 5. So we got the average waiting time of 9.2 ms. Now to get the turnaround time, the most process A who entered the most updated process A who enters the CPU, the time finish of it, we will subtract it to the arrival time. So 20 minus 2 is equal to 18 ms. Then after that, the most updated process B, who enters the CPU, the time finish of it is 14 minus the arrival time which is 5 is equal to 9 ms. That is the turnaround time of process B. Then the turnaround time of process A is 18 ms. Then after that, to get the turnaround time of process C, the most updated process C who enters the CPU, the time finish of it is 23 minus the arrival time which is 1, so it's equal to 22 ms. That is the turnaround time of process C. Then after that, the most updated process D who enters the CPU, the time finish of it is 3 minus the arrival time which is 0, so 3 minus 0 is equal to 3 ms. Then after that, the most updated process E who enters the CPU, the time finish of it is 21, then minus the arrival time which is 4, so 21 minus 4 is equal to 17 ms. In order to get the average turnaround time, we will add what we solved from process A to E. So 18 plus 9 plus 22 plus 18 plus 9 plus 22 plus 3 plus 17 is equal to 69. That is the total of. Then we will divide it by how many processors we have. So 69 divided by 5. So we will get 13.8 ms. That is the average turnaround time because we add the 18 plus 9 plus 22 plus 3 plus 17 is equal to, we got total of 69 divided by how many processors we have. So since we only have time 5 processors, we divide it by 5. So 69 divided by 5 is equal to 13.8 ms. Thanks for watching.